Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level tessellation puzzle. So it's not Sudoku, it's kind of has some similarities, but probably not enough to basically label it a Sudoku variant. Anyways, let's get to the naming of what the name of the puzzle is. It's called Entropic Arrow Tessellation by Michael Lefkowitz. And here are the rules. We have tessellation rules where we need to fill each cell with a digit from 1 through 9. And cells sharing an edge cannot have the same digit. So for example, if this is a 9, since this is a 9, none of these digits can be a 9 because they all share an edge with it. Also, each horizontal row and vertical column contains a non-repeating consecutive set of digits, like for example 2, 3, 4, 5, and 6 in any order. So these are essentially, every row and column essentially acts as a Renban line in that row and column. So that's basic tessellation rules. We also have entropic arrows, where a digit on an arrow counts how many cells in the indicated direction are in this same entropic group, which is the low digits 1, 2, 3, the middle digits 4, 5, 6, and the high digits 7, 8, and 9 as itself, including itself. So that means this could be a 4, in which case these are all 4, 5, and 6 as possibilities for this these 4 cells, as they must be the same. There must be that amount of the same entropic cell as its points at in their respective diagonal or column or row here, right? So since this is pointing that way, if this was 4, then all 4 of these would have to be the same entropic set, because we have to have 4 of them here, right, in this direction, including itself. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so this has to be a low digit, because it's 3 at most this way. These have to be low or middle. These must be the exact same digit. So I guess we'll mark that as a yellow. So these are exactly the same, and it could be blue or green. This is also blue or green this way. This must be blue or green because it could be 3 or 4. It could be up to 4, I should say, digits seen in this direction, which are the same as itself. And any column and row can only have 3 at most of the same entropic set. So this has to be, it can't be 1. So first of all, these are low, but this can't be 1, because if it's 1, you have to have 2 and 3 also somewhere on this line. So therefore, it can't be 1 here. So this has to be 2 or 3, right? If it's 3, these have to be 1 through 7 here. Same with this. This cannot see 1. So this also has to be 2 or 3 for the same reasoning. So these digits have to be 1, 2, 3, or 4 as possible. I guess this could go up to 5, really. So we could have 1 through 5 here. And this is 1 through 5 here, and 1 through 5 here. This similarly still can't be 1. So it could be 2 or 3 here. So these have to be... You cannot have 3, 4, and 5 here, because you have to have at least 2 low digits here. So this is 2, 3, and 4 at most. So we have 1 through 4 here. So this is low or medium. This is low or medium. These are low or medium. But this could be 3 with 4 and 5 there. This has to be either 1 through 7 or 2 through 8 here. If this has 3 low digits here, it's 1 through 7. If it's 2, it has to be 2 and 3, so that would be 2 through 8. So we have 1 through 8 here. We're not sure then. This can't be, this has to be at most 4. Okay. This is the same as that, so this could be 1 through 5 here. This is 1 through 5. So this, if we are guaranteed 2 and 3 have to be in this row here. So this cannot be 2 or 3. So if it's low, it's 1, which would be the same one as that one, because these have to be pointing at the same amount. So this cannot be 1 this way. So this must both be, they must both be green. So this is 4, 5, and this is the same digit, right? If we have 4, this could be up to 5. So if we have 4 here and 4 here, this could be 5. So that's possible. If this is 2, 3, 4, this has to be 5, which means 4 has to be there. So this cannot be 4 here. Which means, so this cannot be green. So we know this is blue or green here. We're not sure which. So if this is 2, 3, 1, 2, 3, this is 4 and that's 4, and then this must be green. If this is 2, 3, 4, this has to be 5, and that's 5, and this has to be green. So no matter what, this is green. So this is always green here. So 4 and 5, that's interesting. That means 4 and 5 cannot be here, and 4 and 5 cannot be here. So how does this column work then? It has to be, this can't be 4 or 5. So if this is 4, that means this is 5, so this can't be, this has to be 2, 3, 4. If this is 5 and that's 4, this has to be 6, 7 with 5. Interesting. This is definitely green, because the only one that can be not green is this one, right? If this is 4, that makes this 5, and then for all of these have to be green. If this is not 4, that means 4 of these are green. So that satisfies that. So this is 4, 5, or 6 here. We know there's a guaranteed 5 here. There's a guaranteed 5 there. So 2 and 3 are both here, guaranteed, which means, well, we don't have anything necessarily there. We know there's a 3 here, because either this is 1, 2, 3, 2, 3, 4, or 3, 4, 5. So this cannot be 3 here. So this is 1 through 9 there. So this is a high, obviously. Hmm. Um, hmm. This is at minimum 3, 4, and 5. That doesn't help much. 3 is here. Therefore, oh, we don't, that doesn't tell us anything. Because the 3 doesn't remove all possibilities from this row, right? Mm. Can we have four greens this way is the question, right? If we have 4, these are all green. Well, really, can we have 5? That's another question. So let's start with that, if this is 5. So say this is 4 and 4. That makes this 5. That would mean this is 1, 2, 3 here. This would be 4, 6. That would mean all of these are green. So we have all of those be green. This can't be blue. No blue here. That means this is 4. So then all of these would be green. Okay. So this would be 4, 5, and 6. This can't be 4, 5, so therefore it would be 6. So this would have to be 7 and 6 there. This would then be 5. That would be 6 there. This would have to be green, so it'd be 4, 5. No 4 here, no 4 here. So far that's okay. This can't be 6 or 5, so this must be 4. We have 6 here. Oh, and then this would be a contradiction, because these two digits would share an edge, and they would be the same digit. So that's not possible. So this cannot be 4 and 4 here. It must be 5 and 5, which means this is not blue. It's green. That's 4. This can't be 5, so that's 4 there. This can't be 4, so it's 5 or 6. This must then be 2 digits that are low that it sees. So this is 2, that's 3. That means this can't be 3, that's 2. So this cannot be 2 here. That means it sees only 2 lows this way. So that must be a low there and is 1. So this cannot be 1. It must be 3 and 4 there as a pair. 4 eliminates 4 here, so that's 3, which means this can't be 3, that's 4. No 3 or 4 here. This is guaranteed to be low. So therefore, this must be green. This is not green here. We have to see 4 greens here in this diagonal. So this is green there. So if this is 2, it would guarantee that it sees 1 and 3 in the row. So this can't be 2. This must be 3. So this must be the digits 1 through 7. Obviously no 3 here, no 3 here. This can't be 1 or 2. So this has to be, cannot be 4. It's 5 or 6 here. No 2 and 4 here because of 2 or 4 in the column. No 3 here because of 3 in the row. This is 4, so it must be 4, 3, 2 to make that a Renban. So this is 3, that's 2. That means this can't be 2, that's 1. So none of these are low. So these are all medium or high. 2 is a low here. That means this can't be low here. This can't be 1, no 1 or 2. This is 5, 6, or 7. This is medium. Cannot be 4, cannot be 5. So this is 6, which makes that 5. No 5 or 6 there. 5 eliminates 5 here, so that's 6. So this can't be 6 and this can't be 6. Where's 6 in row 4? It must be here. We have 3 here, so we don't know what these are. No 5 here, no 4 here. So this could be still 2 lows. Okay. We have 1 through 7 in column 6. So that leaves this as 6 can't be here, here, here. So 6 has to be there. Remaining digits then 5 cannot be here or here. So 5 has to be there, which makes this a 2-7 pair here. This cannot... 2 cannot be any of these digits here. 3 can't be any of these digits here. Actually, I guess 3 could be here. So we could have 3 with 4 and 7 here. That is possible. Or it's 4 through 8. And this can't be 4, so 4 would be there. Or you could have 4, 5, 6 with 7 and 8. Or it could be 5 through 9. So those are all possible. But 9 cannot be on column 4 because that's... You can't have a 2 through... You can only have 2 through 8 on a 7th length Renban. Remaining digits in... So where... Yeah, remaining digits in column 5. We have 4, 7, 8, and 9. 5 eliminates 5 here. We have a 4-7 pair in row 4, which eliminates 4 and 7 in the rest of the row, so no 7 here. It's 5. This can't be 4 because of 4 in the column. So we have 5 here. Remaining digits in row 3. We could have 7, 8, and 9. That's perfectly fine. We could have 4. 4 can't be either of these. So if we have 4 here... you could have 3 here and potentially 2 there. Or if it's 4, 3, 7 works. So those are all possibilities. 9 cannot be here because, again, the way that that works. This has to be 4 through 8. No 4 or 5 here, so it's 6, 7, or 8 there. Okay. This is 2, 7 as a pair, so this can't be 7 because of 7. It shares an edge with both of these. This can't be 9 because it shares an edge with both of these. Or it can't be 9 because of 9 in the row, I should say. None of these can be 2. And none of these could be 3. So if we have to have a 5-length Renban, which has a 3, that means we can't have 2 with it. So 3 would have to be there. 7, 8, and 9 would force this to be 8 and 9. But you could have 4 through 8. So then this could be 7 or 8. Or we could have 3 here. 4 eliminates 4 in the rest of the row. So we're guaranteed this is 7, 8, or 9 here. We are guaranteed one of these is a 9. Okay. Remaining digits in column 4. We could have a 1. 3, 6, 7, 8. No 3 or 6 here. Because of 3 or 6 in the row. We have 6 here, so it could be 2 through 6 here. No 6 obviously there. Or 7, 8, and 9. No 3, 5, or 9 here. No 4 here. We have to have a 5 somewhere in column 3. And 5 can't be here or here and here because a 5 is in the row, so 5 has to be here. That means this can't be 5 here. So this is either 1, 2, 3 or 1, 2, 3, 4 here, which means this can't be 2. So we have a 1 or 2 here, which means the rest of the row cannot be 3 through 9. So there we cannot have a 9 here. We can't have a 9 here. Where is the 9 in column 5? Can't be any of these digits. It has to be here. So that's 9, which makes this 5, 6, 7, 8, 9. So it's 7 or 8 here. This is 7 or 8 here. We cannot have a 2 here because we don't have access to a 3. So we have 7, 8 as a pair here, which means this can't be 7 or 8 because it shares an edge with both of them. So this must be 6. We need access to a 7, but any of these could be 7. We need a 3 in column 4, so the only place is possible is here. So that's 3, which means this must be 3, 4, 5, 6, 7. So that's 4. This is 7. 4 eliminates 4 here, so that's 7 and 4. 4 eliminates 4 here, so that's 8 and 7. 7 eliminates 7 here, so that's 2, which makes that 7. 2 eliminates 2 here, so that's 1, which makes that 1, 2, and 3. This can't be 7 here. We need a 3 in row 6, so this is 3. 7 and 8 eliminates 7 and 8 here, so it's 1. That means this can't be 7 or 8. It's 4. 7 eliminates 7 here, so that's 8, which makes that a 7. And that's how you solve it. Yeah, fairly straightforward on these entropic arrows. And if you've done a decent, or if you've done some tessellations before, there are certain restrictions you have in certain places. Like, for example, you'll always have a 5 in rows 3 through 7 and columns 3 through 7. So you always have to be able to place that somewhere. So that's always very helpful. Anyways, I hope you enjoyed the solve, and I'll see you next time on Frank Puzzles. Take care.